They send you like a coupon basically in it, and you have to put in your code when you go online.
So this is, I just want to show this to let you know that these are another option you have available to you. They're not used nearly as much as cylinders.
Rotary actuators convert pneumatic energy into a rotary mechanical force. Applications that require high torque but limited rotation often utilize rotary actuators. The two types of rotary actuators are the vane and the rack and pinion. Vane rotary actuators are generally smaller and less expensive than rack and pinion actuators. However, they are limited in rotation. Typically, a single vane actuator is capable of rotating up to 280 degrees, while a double vane actuator is limited to about 100 degrees rotation.
So I'm going to stop it there because you're not going to get into rack and pinion actuators. But as part of the cylinder ordering, they give you the option to order a rotary actuator instead of a cylinder. And what this does, imagine a shaft sticking out of this component. So when you put pressurized air in, you get that internal mechanism to rotate, which means that that shaft that sticks out is rotating for you. There's a lot of different things you can do with that. It all depends on what the task is and what you're trying to do, but anything that requires a limited rotation would lend itself well to something like this. If it requires a constant rotation of multiple revolutions, a better application for that would, or a better provider for that would be an electric motor. Because this, once it gets to the end, it has to come back. And again, like I talked about earlier, the simple motion profile of pneumatics means that you know where you are when you're starting, and you know where you are where you're ending, but in the middle, you don't really have a whole lot of control over. So any fine positioning, or anything where you're not either at the beginning or at the end, I would look elsewhere for.
Who would be using it for finders? Moving a robot around a specific location.
Don't do that. Right?
This would be good for like rotating a flag around a circle or something.
Yeah. For style
Only
points.
part of a circle.
All right. So that was the rotary actuator video. We just did that. And then the final clump of components here. This is kind of just the miscellaneous other stuff. First, does require, if you are using pneumatics, there are some minimum ground rules you have to follow, and these are part of that. So you have to have a pressure gauge on your compressor circuit. So like we talked about, all this stuff is 60 psi, all this stuff might be 40 psi. What is this? So you have to have a pressure gauge so that at a glance you can see what your pressure is in that portion of the circuit. You've also got the pressure switch, and this year it's going to be a little different because there's a new controller. I'm sure it'll be really similar, but last year and previous years, the pressure switch is what controlled basically the on-off of the compressor. So as you're competing and running around, you don't have to worry about turning the compressor on or turning it off. It's just automatically controlled by that pressure switch. So when the pressure in this storage portion of the circuit falls low enough, the compressor kicks on, and then once it gets up to pressure, it kicks off. With the compressor, if you're limited to 120 psi, once you build up this portion of the circuit to 120 psi, there's nothing more that that compressor can do. It's kind of a balance of pressure at that point. It can't stuff any more compressed air in because it doesn't have the pressure it needs. So at that point, that's when the compressor turns off and goes into standby mode until you extend the cylinder, the pressure in that area goes down because you've used up some of that stored air, and then the compressor comes back on to replenish it. And then the final little thing on the end here, that is the vent valve, bleed valve. Basically just a turn valve that in the closed position doesn't do anything, and then when you turn it, it opens up and vents the system. And that's actually important for when you go to work on the system, taking a line apart, cutting something, or disconnecting a fitting. If you're going to work on it and there's compressed air in there, that's trapped power that is going to come out. So before you ever work on something, you want to vent the system to make sure that it's safe to start ratcheting on. this is a kind of a pictorial, I guess, of that system we were looking at. So what it was really designed to do was show how the controller sort of interfaced with the rest of the system. So you've got the controller monitoring this pressure switch and the spike relay that puts power to the battery or doesn't. So that pressure switch feeds its signal to the controller tells the relay whether to turn it off. And then also you've got the two spikes that are telling either one of those solenoids to turn on or off, which works your cylinder. You're also going to get a handful of fittings, flow controls, different things that you can add into the lines with the tubing. So what you can do with a flow control at a device is regulate how fast it moves. You can't change it as it extends or retracts, but if you want it to go slow, you can slow the entire stroke of the motion down to a fixed level. The tubing you're going to get with your kit is fine to use. It comes in different colors if you want different colors. It comes in different lengths and whatnot. The important thing to remember if you do need to get more tubing is that you get the right size and the right wall thickness, because depending on how thick the wall is, that thickness, that'll dictate how much pressure the tubing can handle. So just because you got a 1/4 inch tube doesn't mean it's going to be rated for the pressure you need to run it at. So be careful when you're picking out tubing, make sure it's the right tubing.
Is there any issue with water?
There is. I mean, I don't know how, being a first year venture, I don't know how much it affects a robot. You can imagine though, if the pump compressor is taking in air, compressing it, and reducing the volume, so there's moisture in the air, and it takes that moisture in as well and compresses it. So don't be surprised if you open up your system and find that there's little droplets of water in it.
We've been using pneumatics for 7 years now, and we've never really had a problem with it, so.
Okay. Yeah, it's a big deal in like industrial applications.
We're not creating enough heat really, are you, to vaporize much of it or to create much water?
Well, yeah, I mean, like Amy said, it's not going to be a big problem. It'll be there, but it's not really going to affect anything. So, does anybody have any questions on the system? You know, how things kind of interact with each other? Okay, so now we're going to talk about, you know, what to be able to do with that. So, based on all the stuff that I've looked at, 90% of the people are using pneumatics to accomplish whatever the task is on that given year. Because pneumatics lends itself so well to motion-based functions, and it is so easy to install and expand and change, it's very frequently used on the bigger motion of the device. So one of the, some of the things I saw, lifting your robot off the ground, you can either do that with a rotary actuator that'll pick up the front wheels, or a cylinder that'll kind of lift itself up. Deploying a ramp or an arm or something out in front of you. Grabbers, I got a picture of one that I'll show you. Flappers, hanging from something. I mean, there's really, whatever the task is, it's probably going to lend itself well to pneumatics. And most of the people are probably going to use pneumatics into it. So, we've got a robot here. Is this anybody's robot? No?
It's someone local, I forget what team it is.
What's that?
It's someone local, I forget what team it is though.
Somebody in the first session, this was their robot, and he talked about it a little bit.